Hey there, I'm Mike Coleman, a developer advocate on the Falco project, and today I want to spend some time talking about one of my favorite Falco features, enrichment. So, if you look here on the screen, you see some Falco output. And now notice all the details in here about the file name, the user, the GUID, etc. When I first saw this, I didn't think anything about it because of course Falco is going to give you all that information. But as I was reading up on Falco, and this is a great book, by the way, you can learn all about Falco. It's well written, easy to follow, technically deep. But anyway, but I digress. So I was reading the book, and it talked about how that output actually gets constructed via a process called enrichment. But what is enrichment exactly? So to answer that question, let's take a step back and work through an example so you can see how Falco observes Linux system calls, or as they're often referred to, syscalls, and transforms them into something that the average person can easily consume. Before we go any further, let's make sure everybody's on the same page. Syscalls are how applications request various operations from the underlying operating system. So let's say I execute this command cat/etc/shadow, which will display the etc shadow file on the screen. So how do we know what system calls are being invoked? With tools like sysdig or strace, we can look at the actual system calls that the Linux kernel is using to execute our command. Normally, this output would be dozens of lines, but I've edited it down significantly to reduce complexity. Okay, so what's happening? First, cat issues a system call to open the file, and notice the file name is one of the parameters passed in. And at the end, you see equals 3. That is the return value for the open function, and it is a file descriptor. File descriptors are how the OS accesses all kinds of different I/O resources, files, networking sockets, pipes. They're essentially a replacement for things like file names or IP addresses. Basically, every action on the etc shadow file that happens subsequent to the open command will use the file descriptor, which in this case is 3. So here you see it reading from file descriptor 3, and then 777 at the end is the number of bytes read. Notice there is no reference to the file name here. If you had only this read syscall, you'd have no idea what file was being read. And here you see it write to file descriptor 1, which is the descriptor for standard out. So this is where it's writing the contents it read from the file out to the screen. Then it closes both those file descriptors and exits normally. So now you understand how the system calls are working. Let's look at how Falco uses that information. There is a standard Falco rule that is set to alert you if someone tries to read data from a sensitive file. If we look at the read syscall, all we had was the file descriptor, and that's not very helpful to an end user. What value is user root tried to open file with file descriptor 3, especially when you realize the value of file descriptors is completely arbitrary. What you really want is the file name, and that's where enrichment comes in. In Falco, enrichment is the process of collecting metadata and storing it in something we call a state table, and adding that metadata to Falco's output messages. In our example, it would be ensuring that we have an entry in the state table that maps file descriptor 3 to the file name etc shadow, so when Falco needs to produce output messages, it has meaningful data, in this case, the file name. We have this enriched data called enrichment fields for all kinds of resources, files, processes, users, etc. So if we look at the template for the output message from earlier, we see things like user.name, proc.name, fd.name, all examples of enrichment fields. So these tables have all this great information, but how does it get there? It's a two-step process. And without going into the weeds too far, Falco has a couple of important libraries. Library scap, the library for system capture, and library sinsp, the library for system inspection. When Falco starts, one of the things that libscap does is collect all the information necessary to build the initial version of the state table. It looks at things like the running process list or procfs, which is a subdirectories in Linux that have all the information about running processes. So by scanning these system resources, we can get an initial snapshot of the system. But how do we keep track of any subsequent changes to system state? That's where the inspection library comes in. One of the things that libinsp does is to keep the state table up to date. So if a file was already opened when Falco started, libscap would add that to the state table as part of the initial setup. Now, if that file was closed, the inspection library would see that closed syscall and remove it from the state table. If a file was opened after Falco had already started, then libinspect would be responsible for adding it to the state table and removing it whenever it was closed. So with those state tables, which are held in memory, Falco can very quickly look up the metadata necessary to create meaningful output messages. We're almost out of time here, but I want to talk about a couple more things. First, I mentioned all the great enrichment data that we can generate for Linux resources, but we also have that same sort of data for Kubernetes and containers. So where does that come from? Well, like we hook into system calls for the Linux data, for Kubernetes and containers, we hook into the Kubernetes API server and the underlying container runtime. By monitoring those resources, we can augment our state tables with all kinds of enrichment fields specific to containerized workloads. Okay, let's wrap up with a quick discussion on some issues you might run into as it relates to enrichment data. State tables are created and maintained by Falco, reading and processing system calls, the Kubernetes API, or output from the container runtime. If we ever get into a situation where Falco has to drop this input data, for example, Falco can't process all the system calls being generated due to an overloaded CPU, then our state tables will either have incomplete data or the data will become stale. For example, if you've ever seen something like file name equals NA, that might mean we couldn't pull the enrichment data for that file, likely due to missing the open system call that initially accessed the file. With Kubernetes, you can face these same issues, but what we often find in these environments is that the resource limits for Falco are set too low. So if you encounter this with container data, try bumping up those resource limits and see if you fix the issue. With host-based issues, you might need to find a way to reduce the overall system load by offloading some of your workloads or increasing available CPU in the case of a virtual machine. Okay, that's about it for today. I hope you found the background information on enrichment as interesting as I did. Now, we are always looking to add great new people into our Falco community, so please find us on Twitter, GitHub, Slack, or LinkedIn. We also host a weekly community call Wednesdays at 9 o'clock a.m. Pacific time, which is 4 p.m. UTC. You can find the Zoom information for our community call via our LinkedIn posts, and I hope to see you on one of those platforms in the very near future.